Welcome to Business Statistics. Today we are going to talk about central tendency measures, why we use these measures, what is central tendency, what are the purposes to use these measures, what are the advantages, and what are the disadvantages. So, the learning objectives of this lecture are here we will, in first phase, we will talk about central tendency, what is central tendency, and what are the techniques to measure central tendency. We will calculate arithmetic mean, weighted mean, median, mode, and geometric mean. All these are central tendency measures. We will also talk about the characteristics, advantages, usage, disadvantages of these measures. Meanwhile, we will identify the position of mean, median, and mode for different type of distributions. One is symmetric and one is skewed. So we will learn like how we can identify a symmetric and skewed distribution and the position of means in each type of distribution and what is the purpose to identify the position of these central tendency measures in different kind of distributions. So first we will talk about central tendency. Actually, central tendency is the middle point of any distribution or set of data. Why we use this measure? When we have a large data set and we need to present or we need to find out some useful information from data set, there are many observation in one data set. So what is the tool that we can use to conclude the overall behavior of a data? Like there are 40 students in our class, and if I want to uh, talk about the age of students in that class, so there are 40 students. It's not possible to convey the age of each student. Like it is a lengthy task. So to to present a data, there should be some central value. Therefore, this central tendency comes in our mind. So central value tells us like this is the center of data and all the data is around this center. So in that case, one of the most common central tendency measure is average. We in our daily life we talk about average. So I will talk, if I want to tell the age of students in my class, I will tell about the average age of students. So average age is only one measure that will represent that whole data. So this is the purpose of central tendency, to represent a useful information from the whole set of data. We find out central tendency of that data, and there are many techniques to measure central tendency of a data. Here you can see these there are three curves, and curve A, B, and C, they shows the location, central location of data. This shows that uh, different kind of distributions and different kind of data have different central locations. So we we will also learn about different distribution, and we will learn that which technique is important with respect to each type of data set. So the first and common measure of central tendency is mean, and commonly it is known as average, and in statistics we call it arithmetic mean. The major characteristics of mean are, While calculating a mean, we use all the values in the data set. For a set of data, mean is a unique value. I mean, mean for one set of data, there is only one mean. It is not possible to find more than one mean for one set of data. Another characteristics of mean is the sum of deviations from the mean is always zero. We will statistically measure this characteristic, and then you will get some better understanding with this characteristic. It is calculated by summing the values and dividing by the number of values. We sum up all the values in a data set, and then we divide by number of values, and that's how we get average or arithmetic mean. So for ungrouped data that is not formulated in frequency distribution form. In previous lecture, we have learned how to convert raw data into frequency table. So if data is not converted into frequency table or frequency distribution, the way to calculate arithmetic mean is different. Uh, so the formula is we sum up all the values that is represented by x, and we divide all the values by n. N represents the size or number of values in a data set. This mu, a Greek letter, it represents the mean of population. You have to understand that there are two types of uh, 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 values for each what I say each type of measure. One is we measure values for, we measure that value for population, and we measure that value for a sample. So for procedure is same, only some letters are different, just to make a difference from population from sample. This summation sign, also known as sigma, and x represents the values in a population, and n is number of values. So we sum up all the values in a population, and we divide with the number of total values in that population, and here we get the population mean. So here is an example. There are 12 automobile manufacturing companies in the United States, and the data is about the patents granted by United States government to each company in a recent year. So these are total number of patents. If you say that these are 6 out of 12 automobile manufacturing, then it would become sample. So in this case, it is population. The data is about whole population in 1 year. For all 12 automobile companies, the total number of patents granted by government, here it is. So the way to find out population mean is we will sum up all the values patent granted to each company divided by total number of companies. These were 12 companies. So we sum up all the values and divided by 12, 2340 divided by 12, and here is the mean. 195 is our population mean. Now we talk about sample mean. For sample mean, the way to find out arithmetic mean is uh, same, but there is only difference between values. X bar represents the sample mean, where summation is represents sum, x represents number of values in sample, and small n. In previous case, here it was capital N, here it is small n. So small n represents the number of values in a sample. Here is the example of a sample. Suncom is studying the number of minutes used monthly by clients in particular cell phone rate plan. So the random sample of 12 clients, they have thousands of clients, they would have thousands of clients. So we got the data for only 12 clients. Someone used 90 minutes, someone used 77, and so on. So arithmetic mean is the for this sample is exactly the same. We sum up all the values, divide by number of values, and here is our arithmetic mean, sample arithmetic mean 97.5. Now we move to another important aspect. This was about ungrouped data. Now we will talk about group data. Before going into further group data, we need to understand the properties of arithmetic mean. We can measure arithmetic mean for interval and ratio level data. We cannot measure arithmetic mean for qualitative data or the two the two lower levels of measurement, that is nominal and ordinal. Number two value property is all the values that are in a group of data are used to compute the mean. Similarly, as I told earlier, mean is a unique value. For one set of data, there is only one mean. If you are going to calculate here, if you are going to calculate in a university, if you are going to calculate in any other location, in any other position, the mean for same set of data would be similar, would be unique. There would be no change in that. And a bigger disadvantage of arithmetic mean is that arithmetic mean is affected by extremely large or small values. To understand this concept, uh, if you have some very small values in your data set, for example, some of the values are very close to each other, like for example, in your data set there are values like values in hundreds, and there are one or two values that are in tens or in ones. These are two extremely small values. These two extremely small values will change the central tendency of the whole data, and the location of mean will be shifted toward towards lower part of the data. Similarly, if a data set have so many small values, but there are one or two extremely large value, like most of the values are tens or ones, and one or two or three values are in thousands, so mean would be affected and would be tilted toward these bigger values. Therefore, this is a biggest advantage of arithmetic mean, that it is usually affected by extreme values, either large or small. Another property of arithmetic mean is that the sum of the deviation of each value from the mean is always zero. It is very important to understand, and you can also check whether your mean is correct or not. If sum of the deviations from the mean is not zero, it means there are some calculation errors, or you have not calculated the mean correctly. To understand this concept, we use this figure. You can see the mean value for this data set is 5. It is uh, this property is explained by this fulcrum. There are some weights on that, and this fulcrum is balanced by a mean value. The mean value is 5. uh, and for this data set where we got this mean value 5, the original values are 3, 4, and 8. If you sum these three values, 3, 4, and 8, 12, 13, 14, 15, 15 divided by 3 would be equal to 5. So mean is 5. The central value is 5. Here you can see these weights are balancing this fulcrum. How? Look, the mean value is 5, which should be in the middle, and the distance of each of the values should be equal from the mean, from like equal distance on upper side and lower side. Here you can see, if we the word was sum of deviations of each value from the mean, so we need to find out deviation of each value. We need to find out the deviation of each value from the mean. What what is meant by deviation of each value from the mean. We need to find out that how far is each value from the mean. So the mean is 5. One value is 3, one is 4, one is 8. How far is 3 from 5? 3 minus 5 is equal to minus 2. 4 minus 5 is equal to minus 1, and 8 minus 5 is equal to 3. So these two values which are which are less from mean should have a deviation in negative, and the value that is bigger than the mean will have a deviation in positive. So if we sum these three deviations, minus 2 plus 1 is minus 3, and minus 3 plus 3 is equal to 0. So if we sum up all the deviations of values from the mean, it would be 0. And here is we have proved this from this example. Now we move to calculate the mean for from group data. Group data is known as the data that is grouped in frequency distributions or frequency. When we made a frequency table, it is called group data. So to find out the mean for group data, first we need to find out the midpoints of each class. Then we multiply each midpoint by frequency of that class, and then we sum up all the values, and we get the arithmetic mean for group data. Here is the formula on the right side. X bar is equal to sum of f into x. F represents frequency, x represent value. So we multiply frequency of x. Actually x represents midpoint, so we multiply frequency with midpoint. Each class midpoint would be multiplied by the frequency of that class, and when we get the values for all the classes, then we will sum up this and divide it by n, and we will get our arithmetic mean. Here is the example for this. uh, Average monthly balance for 600 customer of a bank. Here you can see the classes that is started from 0 to 49.99, then 50 to 499.9. All these are classes, and here are the frequencies. For first class, frequency is 78. For second class, it is 123. For third class, it is 187, 82, and so on. Total frequency is 600. Here is the calculation of arithmetic mean on the right side of this slide. First we need to find out the midpoint, and in previous lecture we learned how to find out the midpoint of each class, then multiplied by the frequency. 25 multiplied by 78, 75 multiplied by 123, 125 multiplied by 187, and so on till the end. And here we got these values. After multiplication, we sum all these values, and sum of all these values, that is 85,350, is the sum of f into x. Now we put these values into our formula. Here we will put 85,350, and n is total number of observations or total number of values, that is represented by sum of frequency. So the total frequency is actually total number of values in group data. So 85,350 divided by 600. Here we get our arithmetic mean for this sample data. Now we move to another important central tendency measure, that is weighted mean. In weighted mean, we use weights of each value, and we measure the mean for that group of data. When some data set has weights, or if that data set does not have weight, we can calculate the weights for each value. The formula is W represents the weight and X represents the value. So value 1 multiply by weight of that value plus weight of second value multiply by that second value plus weight of third value multiplied by that third value, and so on up to n. And then we divide by the weights, weight of first value, weight of plus weight of second value, and third weight of third value, and so on. So here we multiply weight of each value and sum of all these, and then we divide by the sum of all the weights. Here is an example to elaborate how to measure weighted mean. There is a construction company that pays employees on hourly basis, and they have three categories. They have paid $16.5 to some employees, and they have paid $19 to some employees, and also they have paid $25 per hour to some employees, and there are total 26 employees. We found that 14 of the employees got 16.50 rate, 10 employees they got $19 rate, and two of the employees got $25 rate. In this case, we can measure weighted mean because we have the weights associated with each value. Like this 14 weight is for 16, like 14 employees, they got 16.5. If we don't estimate weighted mean for this set of data, in that case we need to write 16.5 14 times, then we will need to write 19 for 10 times and 25 for 2 times, and then we will sum all these values, and we will divide these values by using the number of values. But weighted mean is a good way or shorter way to find out these type of to find out a mean for these type of data set, where we have some associated weights for each value. So in this case, the first value is 16.5 and the associated weight is 14. 16, actually this is, you can also say 14 is the frequency, so it is just like group data. So frequency of this value is 14. 14 multiplied by this value 16.5 plus 10 multiplied by 19 plus 2 multiplied by 26 and divide by total weights, that is 14 plus 10 plus 2, 471 divided by 26, and we got the mean value for this set of data, that is 18.1154. Another important measure for mean is geometric mean. It is very useful when we need to find out average changes of percentages or ratios or indexes or growth rate over the period of time. Geometric mean is useful when we want to find out the change over the period of time. Arithmetic mean does not provide the change over a period of time, but geometric mean is a useful tool that provides the change or growth over the period of time. And geometric mean is also used in economics, in business finance, in marketing, and many other different areas. Okay, one important property of geometric mean is that geometric mean is always lesser than or equal to arithmetic mean. If your geometric mean is greater than arithmetic mean, it means there are some calculation mistakes. So the geometric mean of a set of and another important thing, you cannot measure geometric mean for negative numbers. So for negative numbers, you need to keep in your mind, like when there are some negative values, we can't measure geometric mean. So geometric mean is always a set of n positive numbers defined as the nth root of the product of n values. Nth root of product of n values means when we take root, the n represents the number of values. Like usually we take it as under root, and under root has a value of 2, but here the value of this root would be equal to number of values. Like if we have four values, the n would be 4, and if we have seven values, n would be 7. If we have two values, n would be 2. Formula is here: geometric mean is equal to nth root of product of values. We will multiply each value, and then we will take nth root of those values. This is not under root, this is nth root. Here is the example. Suppose we receive a 5% increase in salary this year and 15% increase next year. The average annual percentage increase in 9 is 9.88 if we take it as an arithmetic mean. Oh, sorry, geometric mean, not 10. Look, so if we measure arithmetic mean, then how would we calculate? We will calculate like 5 plus 15 is 20 divided by 2. This would be 10. So arithmetic mean represents 10. The average increase is 10, but geometric mean says average annual increase is 9.8 is 886. How? We will calculate it using this formula: product of all values, like 5 into 15, and then we will take nth root. These are two values, so the nth root is 2, under root 2. So root 2, the answer would be 9.886. You can calculate using your scientific calculator. Here is another example. These are another important point. These are in percent. So percent, to convert this percent, because this is an increase, so we will use this is 5% increase. So our previous salary was would be 100%. So 1.05 will be used instead of only 0.05%. So it is 1.09%, where we'll convert this, when we will subtract 1 from this, we will get the actual increase. Or you, if you feel it difficult, you don't use this 1 with these values, just use 0.05 and 0.15, and then you will get the actual value. Another example of geometric mean: the return on investment earned by a construction company for 4 successive years was 30%, 20%, 40%, and 200%. So we need to find out the geometric mean rate of return on investment. So, the way to find out geometric mean is we need to find out product of each value. So we will multiply, these are in percentage, so we will convert it into we will convert this percentage into numeric form. That would be 0.30, 0.20, 0.60, and point and 200% is 2.0. Then we will multiply all these values, and we will take a fourth root, because these are 4 values, and the answer would be 1.294. and we will subtract 1, it would be 29.4%. The second important measure of central tendency is median. So first we talk about the mean values, and there are 3 type of mean: arithmetic mean, geometric mean, and weighted mean. Now we are going further to find out another measure of central tendency. It is known as median. Median is known as the midpoint of any data set or values in some order. To find out median, first we need to arrange values in some order, from largest to smallest or from smallest to largest, anything you want. Then we find out the exact middle point of that data. So the property of the median is that exactly equal values would be greater or and less than the median. So actually median cuts the total data into two equal parts. Here is the formula to find out median: n plus 1 divided by 2. This formula does not shows the median value, but it shows the location of median. This formula shows the location of median. We find out the location, and the value or item on that location is the median for that data set. How? We will see this example. The ages for a sample of 5 college students are 21, 25, 19, 20, and 22. First, we need to make this array of data into an order. We use this in ascending order. We arrange this data in ascending order: 19, 20, 21, 22, and 25. So the formula is n plus 1 divided by 2. How many values are there? N represents the total number of values. There are 5 values. 5 plus 1, 6. 6 divided by 2, 3. This represents that the value, the third value on this data is actually median. 1, 2, 3. This is the third value. So the median is 21. Another example is the height of 4 basketball players in inches are: one is 76 inch tall, one is 73, 80, and 75. First, we need to arrange this data into ascending order, and you can also arrange this data in descending order. The answer would be same. There will be no harm to median value. We arrange this data into ascending order, and the formula to find out median is n plus 1. There are 4 values. N is 4, so 4 plus 1, 5. 5 divided by 2 is 2.5. 2.5 represents that 1, 2. This is 3. So the value of median is between these two values. How we will find out the median? So it is in the middle, actually 2.5. So middle of this second and third value is 2.5th value. So how we can find out the middle? We will plus 75 and 76, then we will divide by 2. So 75 plus 76 divided by 2 would be 75.5. Median value is 75.5. This is another example of median value. These are patient treated in emergency room on 8 consecutive days. Here is the data. We arrange this data into ascending order and descending order, and the median value is, there are 8 number of days, 8 values. 8 plus 1 is n plus 1. 8 plus 1 is 9 divided by 2. So the value is 3.5. Here it would be 3.5. So how we will find out 3.5th value? 43 plus 35. We will divide it by 2, and it would be 39. Now we move to the median for group data. How we find out median for group data? It is a little bit lengthy process. First, we need to calculate the cumulative frequency. As I told you earlier, group data means data that is presented in frequency distribution form, or there is a frequency table, or you have constructed a frequency table for that type of data. Now, first, to find out the median for group data, first we need to calculate the cumulative frequency for each class. And why we measure cumulative frequency for each class? We need to find out the location. Previously we learned about ungrouped data, and the formula we used, n plus 1 divided by 2, was to find out the location of median. So here, because we have classes and each class have some frequency, so first we need to find out which class actually has the median value. For that, we need to find out, first we need to understand what is total frequency. The total frequency of this data is 600, and we will use the same formula to find out the location of median n plus 1 divided by 2. So n plus 1 divided by 2 is 300. Like where the where now we have to find out which class actually has this 300th value. It is not the 300. This is not the this 300 doesn't shows us that value. Actually it shows the number of that value. So in total 600 values, the value that is on 300th position is actually the median value. So because in frequency distribution we don't have actual values, so we need to locate first we need to locate the class which has this 300th value. uh, for that we need to calculate cumulative frequency, and the cumulative frequency will tells us where is the location, in which class the 300 value is located. 78, the cumulative frequency of first class is would be exactly same, that is 78. Cumulative frequency of first of second class would be 78 plus 123. So this is 201. Still it shows that in these two classes we have total 200 values, but actually we are interested in 300th value. So we will move further. We will find out cumulative frequency for third class. We will calculate cumulative frequency of for third class, that would be 78 plus 123 plus 187. This is equal to 388. This shows that in in first two classes we have values, we have first 200 values, and in third class we have values above, we have values from 200 to 388th. Like 180, there are 187 values, so 201th value to 388th values are in third class. This shows that this class is actually the median class. This class has median value. We have located the class. Now we move further. What is the formula? When we find out the median class, we use this formula on the left side of this slide. N plus 1 divided by 2 minus f plus 1 divided by fm, and the answer of this would be multiplied by W plus LM. Now we will understand what are these letters tells us. N is the total number of values, that is total frequency. F is the sum of the class frequencies up to but not including the median class. Like sum of class frequencies up to median class but not including median class. In our case the median class is third class, so F would be the frequency of first two classes. We will not include median class. Fm represents the frequency of median class. W represents class interval width, and LM lower limit of median class. What is the lower limit of median class? In our case, lower limit of median class is 100. Now we put this data into formula. In our example, n is total number of frequency, that is 600. What is f? F represents sum of all the class frequencies up to median class. So in previous example you can see sum of all frequencies up to median. This is median class, the third class is median class, so the frequency of previous two classes is 200 and 1. FM. FM is the frequency of median class. Frequency of median class was 187. W represents class interval width. Here you can see width is 50. So we use 50, and LM is lower limit of median class, that was 100. We put all these values in this formula, and by calculating we got 126.35 is the estimated sample median for our example. Now we move to the properties of median. Median has the one characteristic is same the mean, that is median is unique for each set of data. There are not more than one median for one set of data. One advantage of median over mean is that it is not affected by extremely large or small values. Therefore, it is known as a valuable measure for central tendency. But there are some other disadvantages which makes mean more valuable than median for deep investigations, or some when we use some sophisticated tools. Mean is more useful because another one is mean. It can be computed for all levels of data. There's a ratio, interval, ordinal, and not for nominal but ordinal. So because we need to make an order in the values. If there is no order, then there is no we cannot find out mean. And mean can be computed for open-ended class if the classes are open-ended, like the lower or upper limit of the class is open. Then we can find out median, but we cannot find out mean for that. The third measure of central tendency is mod. Mod represents the uh, frequent observation is mod, or it is also known as modern value. In this example, you can see these are the respondents who like some bath oils, and the uh, length of each bar represents the number of responses on that choice. You can see the second choice, that lemor is a bath oil that is used and liked by most of the respondents, more than 350, around 375 if I calculate the length of this bar. Uh, so most of the people, they like this oil. That's why this is the modern value, because this is the most repetitive value. If we see 100 people say amor, some around 190 people say soothing, some called smell nice. So these are the responses on various bath oils, and the most response is on second value. So it is the mod. Now we move to another example. There are the annual salaries of managers in selected states of USA, and the what is the model salary. For to find out the model salary, we need to see that which value is most repetitive. 35,000, it is only one value, it is repeated by only one. 49,100, not repeated. 60,000 repeated by 1, 2, 3, 4, and 5 and 6. So 6 times this 60,000 is appears 6 times, and all other values you can see are repeated less than 6 times. Therefore, the mod value or modern value or model value for this data set, not modern actually, It is model value. So model value for this data set is 60,000 because it is repeating most often. The way to calculate mod for a grouped data is little bit uh, uh, little bit tough. The way to find out or the formula is here. LMO. You cannot, if you are confused by these subscript, you are allowed to not use these subscripts. D1 over D1 plus D2 multiply by W. L represents the lower limit of model class. D1 represents the frequency of model class minus the frequency of class directly below it. D2 represents the frequency of model class minus the frequency of class directly above it. So D1 is the frequency of model class minus frequency of above class above the model class, and D2 is the frequency of model class minus frequency of sorry, D1 is the below and D2 is for the class that is above the model class, and W is the width of model class interval. Actually, it is the interval. So in our class, in our example, the model class is third class because it has the highest frequency 187. The class which has higher frequency is would be considered as model class. Then to find out the values in that model class, we have formula. L represents the lower limit of the model class. Here you can see the lower limit of the model class is 100, so we put 100 over here. D1 is the frequency of model class minus the frequency of class above, below it. So below class is 8. Below class, the next class, fourth class, has a frequency of 82. So 187 minus 82 would be 105, and D2 is the below is the second class. 187 minus 123 would be 64, so D1 is 64, and for D2 below class, directly above, like it is above than that class, so because it has higher value, second class, fourth class is above class because it has higher value. So 187 minus 82 is 105, so D2 is 105. We put all these values. W, the interval, is 100 minus 150, actually 50. It is 149.99, actually is 150. So or the interval is also calculated as the lower limit of first class and the lower limit of second class. Next class is also we used to find out the interval of the classes. So 150 minus 100 would be equal to 50. Here we put all these values in this formula that I elaborate earlier. Values, by calculating these values, we got these values: 100 plus 0.38 multiplied by 50, and finally the mod for this set of data is 119. So the estimated mod for this set of data is 119. This is for group data, and for ungrouped data it is very simple. We need to find out in total observations, we need to find out which value is most repetitive. And one thing you need to keep in your mind, that there might be more than one mod for a set of data. For example, there are more than one values that are equally repeated. For example, two values that are repeated by 5 times, so those two values would be mod values. Here is the example of a data set that has two mods. Here you can see 1 1 1 is repeated by 3 times, and 4 4 4 4 is also repeated by 3 times. All other values, some are repeated by 2 times, some are repeated 1 time, some are 2 times. So 1 and 4 both appear 3 times. This type of data is also known as bimodal distribution. In this type of data, we have two mods, 1 and 4, both are mods. You need to understand that mod has more than one value. It is not unique. The previous two center tendency measures, that was median and mean, both had unique values. For each set of data, there were only one arithmetic mean and one median, but there might be more than one mod for a set of data. Now we understand the relative position of mean, median, and mod for a distribution. There are three types of distribution we are going to discuss here. One is symmetric. It is also known as normal distribution, or you can say the first graph on the left side, it shows symmetric or normal or zero skewed distribution. Another one is, the second one is actually skewed. So there are two, actually there are two groups, symmetric and skewed. In skewed, there are further two categories. One is known as positively skewed, and other one is known as negatively skewed. In symmetric or normal distribution, mean, median, and mod for that data would be same. Here you can see mean, median, mod is same. Why it is called normal distribution? Because you can see there is a bell-shaped graph. If you draw a graph over here, it would be bell-shaped. The right and left side are equal. Exactly number of values those are lower than the mean would be exactly values, distance of the values would be equal from the would be greater than from the mean. And also in median and also in mod, both in three center tendency measures, the values on right and left side of these center tendency measures would be equal. Now we move to another distribution that is known as skewed. So as I told earlier, there are two types of value of skewed distribution. One is positively skewed and one is negatively skewed. In positively skewed distribution, median, mod, and mean have different locations. They are not equal. Mean is is greater, median is greater than is lower than mean, and mod is lower than median. Here you can see mean is the largest, median is the second largest, and mod is the third largest. So the why it is called positively skewed? The tail of the data, the tail, the most of the values are clustered towards positive, or you can say the tail. Here is the tail of this data. The tail of the data is towards positive. So we understand positively skewed by looking at the tail of the data. There, here is the tail. So if the tail of data is towards positive values, it is known as positively skewed. Another one is negatively skewed data. When the tail of the values is toward negative, here is the zero value. You know, this is the graph, and this corner shows a zero. Beyond this zero, there are negative values on the left side. So when the tail is on left side, it is known as negatively skewed distribution. Another way to understand a negatively skewed distribution, if you have a data set and you are asked to find out the skewness of the data, how you will find out? You will measure mean, median, and mod for that data. If mean is lower at lower side, median is greater than mod, or sorry, mean, it shows that this is negatively skewed distribution. And the mean in negatively skewed distribution, mean is smallest and in positive skew distribution, mean is largest, and in symmetric distribution, mean, median, and mode are always equal. Here is today's lecture. Thank you very much for listening.